Now see here average power associated with LCR series circuit. So in LCR series circuit, suppose you have taken EMF at any instant, that is E is equal to E naught sin omega t, and current at any instant you have taken I is equal to I naught sin omega t plus phi. Phi is the phase angle, phase difference between the voltage and current. Then the power at any instant can be written E into I, that is E naught sin omega t and I naught sin omega t plus phi. We can solve it, that is P is equal to E naught I naught, we can write sin omega t. Here we can break this sin omega t here, sin omega t cos phi plus cos omega t into this is your sin phi. I have used here the sin A plus B. Now we can write P is equal to E naught I naught. Here sin square omega t cos phi plus, here sin omega t cos omega t, sin omega t cos omega t sin phi. We can also write here the P is equal to E naught I naught, here sin square omega t cos phi plus, here we can write 1 upon 2 sin 2 omega t and sin phi. So we can get the total work done in one time period, that is in the total time interval. So we can write dw upon dt is equal to here E naught I naught sin square omega t cos phi plus 1 upon 2 sin 2 omega t sin phi. This is here the total work done in this case, work done upon time. Here we can calculate work done in one cycle. So we can write here dw is equal to E naught I naught. Here we can integrate here, we can take here the cos phi is common here, we can integrate 0 to t sin square omega t dt plus, here we can take common 1 upon 2 sin phi and 0 to t sin 2 omega t dt. Now in this case, we can write the other steps here and we can integrate here the part by part. So here now just see the steps. Here we can write, we can integrate also here. So we can write w is equal to, and in this case here E naught I naught, this is cos phi, and here sin square omega t can be written 0 to t 1 minus cos 2 omega t upon 2 dt plus, and average value of sin 2 omega t is 0. So this whole step will be 0 here. So this we can write directly 0 here. Now we can take 2 outside. So omega naught and I naught by, that is E naught I naught by 2, and now cos phi is also outside. Integration of this will be only t, because again the average value of cos 2 omega t is 0. So we will be getting w is equal to here E naught I naught upon 2 cos phi, that is t into t. So we can calculate average power. So see here the average power is here the total work done upon total time. So the total work done is this much. So average power is equal to work done upon time. So that will be equal to only E naught I naught upon 2 cos phi, because t will get cancelled. So this is the average power consumed in LCR circuit. So we can also write here average power is equal to E naught upon root 2 into I naught upon root 2 cos phi, and that will be called P average is equal to E RMS I RMS cos phi here. Here in this case cos phi is known as power factor. So, see here average power in LCR circuit, it does not only depend on the V and I, it also depend on the phase angle, that is the cos phi. So, if you are talking about the only L circuit where is only inductor is there or only capacitor is there, phi is equal to 90 here. In that case phi is 90 in case of the capacitor or inductor, therefore, the cos phi will be equal to 0 and cos phi is 0, that means power factor is 0, therefore, average power consumed is 0, and in this case whatever the current is flowing, that current is known as wattless current. Similarly, if it is only the pure resistance circuit or ohmic resistance is there, then in that case phi is equal to 0 you are taking, and you will be getting, if the phi is equal to 0, then we can write here phi is equal to 0, that means cos phi is equal to 1, and that is your P average is equal to E RMS and I RMS. So, there is the maximum power here in this case when it is the pure resistive circuit here. So, in case of the inductive and pure inductive or pure capacitive circuit, average power is 0, whereas in case of the pure resistive circuit, average power is maximum, that cos phi is equal to 1 here.